get right to the homework. So at this moment, we should know this. Right. We should know these things. Okay? We should know that tangent is sine over cosine, cotangent is cosine over sine. Those are the cotangent and tangent identities. We should know that cosecant is 1 over sine, secant is 1 over cosine, cotangent is 1 over tangent, and obviously if you flip those, 1 over secant sine, and so forth. We should know that sine squared plus cosine squared is 1, and that if you divide everything by cosine squared, then tangent squared plus 1 is secant squared, and 1 plus cotangent squared is cosecant squared. And you should know that sine is odd, cosine is even, and tangent is odd. You really don't need to know these. Okay. You could know these as well, but that's okay. Right? So just using those, we're going to do some identities. Right? So that is to say, let me give you an example, that if you saw cosine theta times tangent theta, you shouldn't be fooled. Right? If I went to Desmos, just to see how fast this thing's rolling right now. Right? So Desmos, there's the cheat sheet. Let's close that because that takes up a lot of RAM. And let's go here, Desmos. You do all this work, and then you arrive at, well, we'll let that work. We'll arrive at cosine times tangent. You should notice that that's actually, what is that? That's sine, right? And so in my math lab, so back in the day, we would be doing all this by paper, and we would say, show the following identity that cosine theta times tangent theta equals sine, right? They're going to do this in my math lab and ask you to prove this, but they're going to just ask you to fill in the steps, right? So you would start off by doing this. You would say cosine theta times tangent theta, and then that equals cosine theta, and then we'll remember that tangent is sine over cosine, and then you'll need to give a reason for that, and this is just like the tangent identity, right? Identity, that's the reason, right? And then what happens? The cosines cancel, right? And you're just left with sine, right? And so then the reason here, I think they call it, they don't even call it canceling. I think they just call it simplifying or something like this, right? Simplifying, right? So that's an identity. So again, just trying to practice that when you see certain things that you can switch them to other things, right? There'll be some context in calculus where if you see something one way, you'll need to switch it to some other trig function. Okay. What about this one? What about cosine theta over secant theta plus sine theta over cosecant theta. Cosecant theta equals 1. Show that. So these have created nightmares for people in pre-calculus, right? And the reason is because, so far up until this point, we've been, I'll give you a math problem and I'll say, do this. Step 1, step 2, step 3, step 4, right? And now with these, it's just like, okay, here, start with this. Tell me why these things end up being equal, right? So as much as I can, I'll try and give you steps for this, right? So one of the things we did for this one is we switched tangent to sines and cosines. So one of the things that you can always do is switch everything back to sines and cosines and see if you get something that looks like that's reasonable, right? Let's use that method. All right, so what's secant? So secant is 1 over cosine. So this is cosine times 1 over secant plus sine times 1 over cosecant, right? So I'm starting on the left, right? And I want this to be equal to 1, right? So then this is equal to, well, what's 1 over secant? Cosine. 1 over secant is cosine. But why is that?
Because secant is 1 over cosine.
That's right. Secant is 1 over cosine, and what we're going to end up doing is start using the language and calling it a reciprocal identity. Right? So cosine is 1 over secant. It's a reciprocal identity. Okay. So that's 1 over cosine plus sine, and then 1 over cosecant is also sine because that's a reciprocal identity, and this is equal to cosine squared plus sine squared. And what's cosine squared plus sine squared? That's 1. Why? Because that is a Pythagorean identity. Right. So this was because of reciprocal identity. And again, I'm giving these reasons. You'll have to give these reasons because my math lab's going to ask for them. Go ahead.
So does a Pythagorean reason, Pythagorean
Identity.
automatically equal 1?
Yes, cosine squared plus sine squared makes them 1. That's the Pythagorean identity. Because x and so what's cosine again? Cosine is the x and sine is the y. Excellent. These are the x and y coordinates on a circle of radius 1 centered at the origin. So x squared plus y squared equals 1. Always, always, always. X squared plus y squared equals 1. Let's do some in the homework. I think it's here. All right. Verify that tangent, can we see this? Yeah. Verify that tangent times cosine equals sine. I almost want to bring this up in my math lab as you do it, but they'll just be drop-down menus, right? They'll just be drop-down menus. So you'll have to fill in each of the blanks. Okay, so I think it's something you probably want to go to the side and do first and try to figure out before. I don't know what works best for you students, but I've been working on these by just going to the side and trying to figure it out, and then try and just work with it inside. Although it is multiple choice, so they might, it might help you out, right? Why is tangent times cosine equal to sine? So tangent x times cosine x. What's tangent? Sine over cosine. And so doing these, obviously, one of the benefits is that you learn these rules pretty easily or quickly, right? So you would instead write sine over cosine, right? And what identity is that? What's the reason for that? I don't even think they ask you for that one, right? But then what they do, separate the quotient on the left, express in we express it in terms of sines and cosines, right? We express tangent in terms of sines and cosines. We then intend to cancel, right? And that gives us with sine, and so they want the reason here for canceling. And so what's their term for canceling? Divide out the common factor. Okay, that's their phrase for canceling. Divide out the common factor. Try this one. Tangent times cosine times cosecant is 1. Right? We're going to switch everything to sines and cosines. Verify that one. Go ahead.
Oh, so number 1, multiple choice is representing the 1.
Yeah, so thank you. So here, tangent becomes sine over cosine, and they want the reason for what we just did. So when we switch this to sine over cosine, we're expressing it in terms of sines and cosines. Then we cancel, we're left with sine. What's the reason? It's because we divided out the common factor. Demonstrate that tangent times cosine times cosecant is equal to 1. And we might see that's because everything just cancels. Everything just flat out cancels. You'll write tangent as sine over cosine. You'll leave cosine alone. You'll change cosecant to 1 over sine, and everything just cancels out. All right, let's write that. What a mathematician would want to see is this, that you start on the more complicated side. It's harder to start with 1 and work to the right. This is equal to sine over cosine times cosine times 1 over sine. Right? That's using tangent identities and reciprocal identities. And then we'll divide everything out, and that leaves with 1. I think they provide us with the choices, with just moving from left to right. Which one gives the proof?
Last
Do we see it's the last one? Right? Tangent sine over cosine, left cosine alone, cosecant 1 over sine. And it's just D. Okay. Questions about what we're trying to do. And again, the point is that, again, you're doing your work and you see this and you're just like, well, wait, I'm supposed to get 1. In the future, you're just supposed to understand that, oh, I have one trig function. This actually may be the answer. Maybe I need to switch it everything back to sines and cosines. How bad does this get? All right. Can you show tangent squared plus secant squared equals 1 plus 2 tangent squared? So when you see something like this and you're not down with all the formulas yet, you always just go back to the cheat sheet, okay, and see what's being related. And it looks like we're definitely going to be utilizing this one, right? Given what we've just seen, given page 2, right? So it's here. We got some tangent squared plus secant squared equals 1 plus 2 tangent squared, right? So we got tangent squared. I'll start on the left. Plus secant squared, right, equals, and then now we need this, we want to show that this is 1 plus 2 tangent squared, right? So here's where you start to think about, so what's great about this is that you know where you need to end, right? I started with some tangents and secants on the left, and I need only tangents on the right, right? So somehow I need some formula that would switch secants to tangents. Is there some formula that relates secant squared to tangent squared? And looking at the cheat sheet, it's precisely this one, right? Secant squared is 1 plus tangent squared. And so we would keep that in mind and just say, well, wait, I'll put all of my past stuff in red. We know that secant squared acts as 1 plus tangent squared. And so this secant just gets to be replaced. And that's all we're doing, right? So this is equal to tangent squared plus 1 plus tangent squared. Why? Because that's a, what's the name for it? What type of identity is that? Pythagorean identity. Pythagorean identity. So then I've replaced this with that, and then it's 1 plus, how many tangent squares do I have?
2.
That's the game. Which answer choice reflects that?
D. That's also D.
Tangent squared plus secant squared is equal to tangent squared plus 1 plus tangent squared, which is 1 plus 2 tangent squared. Try number 4. Don't take any questions on 3. 4? Try 4. 4 is hard. We're going to return everything back to sines and cosines for just a moment. I think I'm going to add a page here to work through this one. All right, so it looks a little bit cumbersome without the drop-down menus, but we'll fill it in as we can. So the first step that we'll try that works a lot of the time is that, first of all, we need to start on the side. And so we'll start on the left. And we'll turn the left into the right. You can do either one. Generally, it's easier to make two things. We have two terms, right? And somehow we're going to make this thing into one term. So secant theta minus cosine theta is equal to, and then the second step is to make sines and cosines. Okay, what's secant? 1 over cosine minus cosine. Right. Now, when we're game planning, it looks like we have two terms that we make into one term. What does that mean about these two things, those two fractions? What are we going to do to make them one thing? Find a common denominator to make them one thing. We have two things that were two terms. We need it to be one term that's multiplying. It looks like we need to find a common denominator. This is 1 minus cosine over 1. Common denominator is cosine. What does this need? Nothing. What does this need? Another cosine. Cosine squared. Okay. Questions about that? Okay, so let's make that remark. So then here what we're doing is we're combining, we're finding a common denominator. And it's because we needed to turn two terms into one term, and finding a common denominator lets us now find one term. That's one thing. Okay. Now we're stuck. Okay, that's going to happen a lot with identities. Okay. So now when we're stuck, we need to go back to the cheat sheet and see if 1 minus cosine squared shows up as anything interesting. 1 minus cosine squared. Was there a cosine squared anywhere here? With a sine squared right here, right? What's 1 minus cosine squared? It's sine squared. Right? If sine squared plus cosine squared is 1, then 1 minus cosine squared is sine squared. Right? So making those switches are important. Right? So whenever you see 1 minus cosine squared, you have to think, oh wait, that's sine squared. You may not want to change it, but you should always have it in your arsenal. And that's true for all of these. When you see secant squared minus 1, you should always think, well wait, that's tangent squared. And just in general, when you see secant squared, cosecant squared, sine squared, cosine squared, any of those, you should be looking at these identities. Go ahead.
Would you have a cheat sheet on my math lab, or was I looking for myself?
Yeah, you should probably bring it to my math lab with you. Yeah, but this is, again, if you type in trig cheat sheet, it's the first link on Google. It's the first hit. I'm running out of battery. No, okay. Trig cheat sheet. Trig cheat sheet, yeah. So 1 minus cosine squared, I'm switching to sine squared. This is because of a Pythagorean identity. All right. Now we're going to cheat. I know that this needs to be tangent sine. I'm going to do whatever it takes to make this tangent times sine, right? So I need this to be tangent and I need this to be sine. And it looks like I already have a sine, right? Right? Well, what's left if I take one out? I got a sine over cosine, and that just happens to be tangent, which is what I needed to show. So I needed to get tangent times sine, so I pull out one of these sines and I'm good, and we just pray that the other thing is what we need it to be, and it is. So, yeah. Start with two things, switching the sines and cosines, find a common denominator, use the identities, and then try and get what you have now to be what it needs to be, by taking away one of the things that we already have and making whatever's left what it needs to be. Now we just need to find reasons for all of these things. Right? The hard part, the real hard part, is when my math app decides to do it differently than what you do. Right? So hopefully they have very similar steps to what we did, right? To see, try and figure this out. All right. this is really hard because they just have a bunch of damn blanks and you just hope to fill the thing in with the right thing, right? So let's see if we can piece this together. This is why this is hard to do online and not on paper. All right, a bunch of blanks. It looks like this should be, should I make this larger? All right. Okay, so it looks like this should be 1 over cosine, right? Right. It looks like they're only changing this thing to something else. And hopefully the reason for that is a reciprocal identity. So this should be reciprocal identity, and it's there. We made secant 1 over cosine, reciprocal identity. Okay. I have no idea what they want us to do for the second equality, right? Let's see what the choices are. Okay. We made a least common denominator. Is that one of the choices?
Yeah.
That is one of the choices. Combine using the least common denominator, right? So then that was, so then the question becomes, do they want this? Hopefully they want that, right? And then that was what we got when we made the least common denominator. And then hopefully we changed that to sine squared, right? And that was a Pythagorean identity. So this becomes sine squared theta over cosine theta. And then we switched, we pulled out a sine and changed the sine over cosine to tangent. Let's see if that fits any of these. It looks like it's B. We rewrote as a product of two trig functions and used a quotient identity. Let's be clear about what a quotient identity is. A quotient identity, I think they have it here. Oh, so this cheat sheet calls these tangent and cotangent identities. These are also called quotient identities. My math lab calls them quotient identities. Okay, so I think that's all, right? View, zoom in. I'll take any questions. Usually a very rough part of class doing identities. Now imagine if you just, we just gave it to you and just said, just work, figure it out. That's how it used to be, right? Yeah, just here, show this is equal to this. Usually it was the worst part of this class. All right, next one. Yeah, go ahead.
Scroll up a little bit.
I can, thank you. We're good?
Yeah.
Okay. Three. Try this one. These are the first problems on the next test. At 6.1, you shouldn't be shocked that the first problems on the test are going to come from 6.1. This one's not so bad, I don't think. We're going to switch that, of course, first up, for the most part, switch that secant into 1 over cosine. 1 over cosine cancels with that cosine. It becomes a 1 over sine. And 1 over sine is cosecant. Just trying to fill in what the choices are. We'll try and fill it in before we start checking answers. But go ahead.
Quickly go back to for the answers.
Oh, for the answer, yeah. So the answers for 4 are, it's apply reciprocal identity, combine using the least common denominator, apply a Pythagorean identity. Yeah, you should take a picture. Secant's 1 over cosine. That's a reciprocal identity. That becomes 1. I think that's going to be like dividing out the common factor. And then 1 over sine is cosecant, and that's reciprocal again.
What if you like on the thing that you don't have to click the button and then
It's going to be dropped down.
Yeah.
Yeah, it's going to be dropped down. Yeah. But when I decided to just print the homework, it just gives you the choices like this. Yeah. What did we do? We applied the reciprocal identity, right? Then we divided out the common factor. Then we again applied the reciprocal identity. Questions about that one? Four. Let's try this one. Secant squared times 1 minus cosine. Oh, I'm sorry, 1 minus sine squared is 1. We know that 1 minus sine squared is cosine squared, right? And we know that secant squared and cosine squared are about to just cancel. Because cosine, it's funny how they changed cosine and not secant, because cosine is 1 over secant. So you're about to flat out cancel those because of a reciprocal identity, and then we're going to divide out the common factor. Yeah, so that's right. So we got to remember so here's the basic one. We got to remember that cosine squared plus sine squared is always 1. So when you run across 1 minus sine squared, that is cosine squared. Right? So this is going to be cosine squared because of the Pythagorean identity, Pythag. And then we know that cosine is 1 over secant squared. That is reciprocal. And then they flat out cancel, which means we're dividing out the common factor. And you're left with 1. Got about 14 of these. Okay, so we're almost halfway.
So secant squared.
Yeah, secant. Let's go to the cheat sheet. Secant. Yeah, so let's go back. So yes, you will be here, and then you're going to be like, I'm sorry, view, right? You're going to be here, right? And you're going to be like, okay, what do I do now? And at this point, when we look at the cheat sheet enough, you'll see that secant and cosine are supposed to flat out cancel each other out, right? That cosine and secant are opposites, and whenever they start multiplying, they cancel each other out. So secant's 1 over cosine, or cosine's 1 over secant. But whenever they're next to each other, canceling should start happening, right? So that doesn't change if things are being squared, right? So that cosine squared and secant squared still cancel each other out. So when we go back here, when you see, I think it's the next one, right? When we go back here, when you see secant squared theta times cosine squared theta, it becomes secant squared theta times 1 over secant squared theta. Because if cosine is 1 over secant, cosine squared is 1 over secant squared. Just using the rules. Oh, let's fill these in. Pythagorean, reciprocal, And looks like we just divided out the common factor. Questions there? How bad does this get? Okay. 5. Let's try this one. This one's super bad. We're going to turn one thing into two things. Looks like the sine squared needs to become two things. What's sine squared? What two terms does sine squared turn into? 1 minus cosine squared. Right? So you switch sine squared into 1 minus cosine squared, and then, we'll see if they don't want us to simplify yet. Then we'll see that it looks like we're going to do some division after that. So a remark earlier is that it looks like they want us to start on the left. I would have started on the right, but when they want us to start on the left, then we have to conjure a way of turning this one term into two things. The Pythagorean identity does that by turning sine squared into 1 minus cosine squared, which makes at least that's two things, right? That's because of Pythag. And then I'll put it on the side, 1 minus cosine squared t. To make them two separate things, you then divide each one separately. And then now you have the two things that you're probably going to need, right? I have a minus b over c. I can just take a over c minus b over c, and there are the two things. If we've done everything right, then that better be secant minus cosine. And it is. They don't want us to simplify immediately, so apparently right there they want 1 over cosine t minus, and they don't want us to simplify? They literally, I'm worried about this step.
Yeah.
Will they take it? They want this?
No.
What do they want, cosine?
They want that.
They want this exactly.
Right.
So they want cosine squared over cosine.
Right.
Okay, good. So they want that. So don't simplify. And then I guess the next step, it looks like we're doing two things. I don't know if they even have a drop down for two things, but we're going to use a reciprocal identity and we're going to cancel out a common factor, and that should give us the answer. But the thing here is that, what do we do? Oh, what are the choices? So we split into two things. What's that choice? We separated the quotient into two terms. We separated the quotient into two terms. Okay. All right, what goes in this blank? What do they want us to do first? Do the reciprocal identity maybe for 3? See, this is where it becomes funky. What do they want us to switch this to? Oh, we divide out the common factor. Divide out the common factor. They want us to do that first. So they want us to leave this as 1 over cosine, divide out the common factor, leave that as that, and then we'll switch 1 over cosine to secant. So divide out the common factor, and then we'll do the reciprocal identity. Okay. So we cancel one of the cosines. It's cosine squared over cosine. One of them cancels, that leaves you with cosine. And then we know 1 over cosine is secant. And then it's over.
I have a question.
Yes.
So we get more complicated after each other.
Say it again.
So we get like more complicated after each other.
Yeah.
It is.
It is. We're about to, yeah.
They're gonna add numbers.
It's going to get hard. What'd you say?
They're gonna add numbers to these. Right?
Oh, yeah, no. I mean, did you not see this cheat sheet? Yeah, I mean, we're going the whole way. We're going the whole way. Right, so there are going to be identities with all of these. Right? So, yeah, perhaps we need to stop and get ready for what's about to happen. So, it's okay, right? We're still going step by step. I'm not going to ask you to do anything that we haven't worked on before. Yeah, so it's pre-calculus, right? The more classes you take, the higher the percentile of math classes you're going to separate yourself, right? So right now you're already in the 80th, 90th percentile, right? Most people don't even take pre-calc, right? In the whole country, right? So then you're going to be taking calc, and my I-Tech people are taking calc too, and yeah, you're about to do some serious stuff. That's okay. That means you're going to get paid. Right? I mean, that's what it means. I mean, if you're doing hard stuff, you're going to get paid. Okay. 3, 4 questions about this. Was it this one? 5. Okay, yeah. I'll take questions about this.
You have to leave it there.
Yeah, that's why I came back to it.
What is 3 and 4?
So 3 and 4, right? So we had this, right? And so now I cancel out one of the cosines, which means I divide out a common factor. So when you can, what we call canceling, they call dividing out a common factor. The numerator had a cosine, has 2 cosines. The denominator has a cosine. We cancel one of the cosines out for each one of those, divide out a common factor. So that one was that one, divide out a common factor. And then the fourth one is that you're left with 1 over cosine. That becomes secant because that's a reciprocal identity. The first thing we did was a clear Pythagorean identity. Again, you have the link to these notes. So this might be the time where the notes come in most handy. I'll link to these notes. I think it's just on D2L. It might even be in the syllabus. All right, we're moving. We're moving. 6, try that one. I think I actually did this one already. This is one of the examples I gave, but I won't say a word. I don't know how many blanks they're gonna have. Oh, did they really end it that quick?
I mean, it's kind
It looks like they're just switching it directly to sine. Right. So here's the step that I thought they were going to put in that I did with one just like this, right? But the notion that this is sine of t times 1 over cosecant. Cosecant. I just need an eraser. Right, so this is times 1 over cosecant t plus cosine times 1 over secant. They apparently don't care about that that step because they immediately, I think, just want you to write 1 over cosecant sine. 1 over secant is cosine. They don't give you that many steps to get there. Right, so I guess that step they don't even want you to write. They just want you to see that that's sine. 1 over cosecant sine, 1 over secant is cosine, and those are reciprocal identities. And then we know that that's sine squared plus cosine squared, and sine squared plus cosine squared is 1. Oh, it looks like they have it all here. So, oh wait, maybe they do want it. Divide out the common factor. So they just put 2 steps into 1. Divide, no, multiply and simplify using, divide out, apply it, and, what do we think it is?
multiply and
Simplify, I like that one, right? So then you would multiply these two, sine squared plus cosine squared, and then use the Pythagorean identity. I like that one. Right, so the step they're saying is that here's what you're going to do next. Well, we have space for it. Then you would write sine squared plus cosine squared, right? And then you would say, yo, that's 1. Right, so that's the multiplying. And then you would simplify using the identity, which is clear as day.
Are you going to be here tomorrow?
2 to 10. 2 p.m. to maybe slightly before 10. I'm going to see Venom. Priorities. I gotta be somewhere at 9:45 Hamilton Mill. Where's that? I can get there about if I leave at 9. 9:45.
Yeah, you can.
Yeah.
Easy. So I get 9:30. I'll be here till 9:30 tomorrow.
You might have to fly a little bit.
Yeah.
Oh, I'm sorry, 9:15. I'll be here till 9:15
Just
tomorrow.
finish at 9 and just
Okay,
take
I
it
appreciate
easy.
that. Take your time. Okay. No, I want to help though, right? Yeah. So again, that's in C2210. C2210. We're there from 2 to 9.
9.
2 to 9. So. All right. 7. Load. Oh, brutal. Oh, not bad. Not bad. It looks like they want us, we want to turn, somehow this all becomes just one thing. All that nonsense becomes one thing. We're using a formula. Here it is. We'll be using that a squared minus b squared is a minus b times a plus b. We'll be using that here. Looks like here they want us to use what? What's sine squared? 1 minus cosine squared. Why? Pythagorean identity. We're going to cheat again. Look where we need to go. We need to go from a place that has fractions to a place with no fractions. Must mean we need to cancel this thing out. 1 plus cosine is going to cancel out because 1 minus cosine squared is just a squared minus b squared. A squared minus b squared. Can we see that this is 1 minus cosine? 1 minus cosine theta times 1 plus cosine theta. You can factor that. 1 minus cosine squared is 1 minus cosine theta times 1 plus cosine theta. This marker is too thick. It didn't used to be that thick. Maybe it's because I'm zooming in. Let's use the basic one. 1 minus cosine theta times 1 plus cosine theta. We're factoring. Hopefully that's one of the reasons they will allow us. Oh, factor the numerator. I like it. There it is. We factor the numerator. And then the 1 plus cosines cancel, and the game is over. Then you simplify. The 1 plus cosines cancel. You're then left with 1 minus, parentheses, 1 minus cosine theta. Distribute the minus sign. 1 minus 1 plus cosine theta. Cosine theta. And so these are horrible, right? Because you're supposed to look at 1 minus cosine squared and it's like, oh, I can factor that, right? I mean, to do these, you need to bring up all of the algebra and stuff, all of it, right? You just need to have it all at your disposal to use at any moment, right? And yeah, that's almost impossible if you're not a math major, right?
So,
Go ahead. Yeah, no, it's hard. It's hard. It's hard. Right? But I keep saying it's easier than what it used to be. Right? What it used to be is that before the technology, I would just hand you out 40 of these for homework next week, and then I'll have to come grade it, right? It would just be a nightmare for everybody, right? And so, yeah, you would have to come up with all these steps yourself, right? So, what are the reasons? So factor out, it looks like we factored here to get this. And then it looks like we canceled and simplified. So we did the Pythagorean identity, we factored the numerator. Looks like we're going to put 2 steps in one, that we divided out the common factor and we simplified. We divided out the common factor and simplified. We factored, canceled out the 1 plus cosine, and the rest was simplifying. Right, so that's a trick. On the final, there is an identity there. So when we practice for it,
How many questions?
oh, that thing is short. I feel like it's only, because I think there are like 10 to 15 questions that they force us to ask you, and I tend to just only give those. Like I think the rest of I think everyone, you have your choices. You have to give those 15, and then you can add whatever interests you, right? But I just tend to just give those, be done with it, yeah. All right. This is not bad because they give you a lot of this, right? So we're going to play with this ourselves first and see whether we can get this. They want us to start on the left, right? And let's see if we can make the right happen. We're almost there to the first break. It's this. I need to make that a little bit smaller so I can get some space. We'll throw it up here. They want us to start on the left. Cosine x, cotangent squared x. Looks like we need to turn this cotangent into cosecant squared. Cheat sheet. Look at the cheat sheet. Looks like 1 plus cotangent squared is what? Cosecant squared. That's all cheat sheet. That's a Pythagorean identity, right? And so it looks like that's probably what we need to do, because somehow we need to change this cotangent into a cosecant with some other stuff. But this is the only identity available to us that would do that, right? So then this is equal to, by the Pythagorean identity, cosine x, and we're going to change cotangent to, what is it now?
1 plus
Cosecant squared x minus 1, right? Because if 1 plus cotangent squared is cosecant squared, then cosecant squared x minus 1 is cotangent squared, right? And then you distribute the cosine and it's over. That's what you need to show. So, you know, it's one of these things where it's just like you're trying to solve a puzzle. Someone says, here's the beginning, here's the end, and here's this big cheat sheet, take me to the end, right? That's the game. Right? And you're just looking for clues about which identities to use based upon where you're starting and where you're ending, right? Then we'll just distribute the cosine x times cosecant squared x. Cosine times this is that, cosine times 1 is that, and that is exactly where we needed to end, right? Let's give the reasons before looking at the choices. This came directly from a Pythagorean identity, right? I think I'm just going to use capital P from now on for that. And then here you're just distributing, right? So that's not so bad. Let's see what blanks they have for us to fill in. Was that 7? 8. Oh no. Was that the bottom of 7? Yeah. 10. No, but it was page 7 here. But yeah, it's problem number 10. That's right. Which one is that? Oh, this is bad. They didn't decide to do the way we wanted it to do it. We have to do it their way. All right. So then, this is really bad.
You scroll
So they want to, I'm sorry?
scroll a little bit.
Up this way?
Yeah.
To 9? So let's do it their way. They want to return back the sines and cosines. That's a tedious way to do it. Cosine times cotangent squared x is equal to, all right then, it's going to be cosine x times, this is cosine squared over sine squared. I'm sorry, yeah, over sine squared. Okay, and then when you multiply, this is going to be cosine to the third over sine square x. And what of it? So it's, first of all, it's either A or D, right? Is that okay? So it's either one of these. And then what do they want us to do? So I don't like this at all. Okay, so then I think they want us to do this, right? So then they want us to change cosine squared to, but it's not reflected in this at all. They want us to change cosine squared to 1 minus sine squared, right? Like this. We're supposed to change this to cosine, yeah. They want us to do that, right? And then they want us to distribute cosine x over sine squared x minus cosine x. Right. So that one's bad.
That's worse.
Yeah, this is worse. So cosine over sine squared is really just times cosecant squared minus cosine. So again, what also makes this hard. So what's good about this is that if you don't have a dictator like my math lab, people will give you different answers, which of course is again a nightmare when you're grading, right? But it looks great. Some people would do it this way, other people would do it the other way. So again, this step is one in which I skip some steps, right? So if you do cosine times 1, you get cosine. Cosine times minus sine squared, that cancels out with this sine squared. You're just left with cosine here. And cosine times 1 over sine squared is this. 1 over sine squared is cosecant squared, and then that's exactly what this is. Which one is that? That is, I don't know how it's this last one at all, right? It's got to be A. Yeah. Okay. Now, I think that you can see that earlier, probably at this step, like this is just so bad. Like cosine squared was never going to be in the denominator, right? It was always sine squared. So you can tell it was never that. So that the first two were disqualified because cotangent is cosine over sine. So that's why these two were both out. And then you eliminated this one because it's sine squared that needs to be in the denominator. So again, you never even needed to go the whole way to do this. More, they get harder and harder. Oh, I thought I was going to take out 12. Yeah, we're going to take out 12. 12 is just a nightmare. Here, 11, we're going to factor. Again, a squared minus b squared is a minus b times a plus b. And therefore, secant squared x minus tangent squared x over secant x minus tangent x is equal to secant x minus tangent x times secant x plus tangent x, right? All over secant x minus tangent x. And then, of course, these cancel. And you're left with secant x plus tangent x, which is what we need to show, right? That's just factoring. Letter is that.
C.
For sure. C.
Sorry. It's not C.
Is that C?
Yeah, it's got a D.
Oh, they changed the denominator for some reason. Tricky. D. Right, so they changed this for some reason. For no reason but to fool us, right? That cancels. What I tend to do with problems like 12 that are outrageous, I'll give this as some extra credit. Do this by hand. Even or odd number? What do you want me to say? An even number or an odd number? Odd will make this worth 5 points. Right? So do this by hand on paper. Hand this to me and I'll add 5 points to your test. Okay. Say it again? Yeah, number 12. Yeah, do that one by hand. It's just super tedious. You might expect you need to.
And get it correct?
It should be right. You should, yeah. No, and I'll look at it. You can bring it to me and I'll be like, no, you need to fix this, fix that. Yeah.
Next day, class.
No, it's due on the day after the test. So you just have to remember after you do the test, just hand this to me in paper and I'll have 5 points. Oh, it's a ways from now. You just have to remember. Go ahead.
Is that on my math lab, or is that in the homework somewhere else that we'll need to?
This one?
Yeah.
It's number 12 on my math lab.
Okay.
Yeah. Yeah.
Can you zoom in?
Zoom in?
Yeah.
Yeah, sure. You need to show. It is hard. It is hard. You don't think I can hear? So yeah, you're just switching everything back to sines and cosines and finding tons of common denominators. This is going to be cosine x over sine x plus cosine y over sine y over 1 plus cosine x over sine x, cosine y over sine y. Common denominators, cancel, blah, blah, everything, and then it comes to this. I don't know how in the world they did this in 2 steps.
You want us to write the source terms as well?
No, you need to give reasons why your steps are true. Yeah, so you're going to have a bunch of equal signs. They apparently used an atom bomb to do this. But yeah, they used some, yeah. Well, they must have put a bunch of steps into one step. So yeah, rewriting in terms of sines and cosines is a nightmare. Right? So this is the first thing you do. But yeah, and that simplifying is pretty brazen too.
Okay, so
Yeah.
I'll see you tomorrow.
That's right. Okay, great. And so 9. Okay, so yeah, 9, we're going to go ahead and work through this. And I think that might be the last one. We got one more after that. Okay. All right, so then 9, starting from the left, secant x minus tangent x squared we're going to write in terms of sines and cosines inside the parentheses. Secant is 1 over cosine. Tangent is sine over cosine. Right. They conveniently have the same denominator. We are ready to roll with that. So it becomes one thing, which is what we need. That's 1 minus sine, which looks like it's sitting right there, over cosine. And now we're going to flat out square the numerator and denominator. That's 1 minus sine, all squared. And then this thing is cosine squared. But oh my goodness. Cosine squared is, what's cosine squared? 1 minus sine squared. And then 1 minus sine squared, using that factoring, is 1 minus sine times 1 plus sine. one of the 1 minus signs cancel, and you're left with 1 minus sign over 1 plus sign, and that ends it. All right, so let's fill in all these steps here. So write in terms of sines and cosines. Right, common denominator. Here we squared things, squared everything, the numerator and denominator. Then we used the Pythagorean identity. We factored the denominator. And we divided out the common factor. And all of that. That's why this is one of the last ones. Now that's almost as many steps as are written here. Right? So then hopefully we'll figure out which ones go in there then. All right, so then that's probably the hardest part, trying to figure out what goes where. So it looks like we've done it okay, right, in terms of sines and cosines. All right, that's what we did first. And then filling this stuff in, what's the next thing that we did? Combine and square? Is that the next thing we did? We combined them by using the common denominator, and then we squared the numerator and denominator. I like that. Combine and square. And then after we combined and we squared, then what did we do? Use the Pythagorean identity, right? This thing right here. Rewrite the denominator using the Pythagorean identity. Then it looks like we need to factor the denominator. Oh. Looks like we really only factored the denominator, but I guess you could say we factored the numerator and denominator. I don't like any of the other choices.
I think they put the 2 steps together.
Yeah. And then number 5, we divided out the common factor.
So they probably run 1 minus sign x
Times 1 minus 9, absolutely. That's what they call factoring. Right. Yeah, yeah. All right. I know. I'm looking at the clock too, brother. Y'all think y'all slick. Let's factor this. We got cosine to the 4th minus cotangent to the 4th. We need to show that's 2 cosecant squared minus 1. So we're going to use the same identity again. That, again, it's just a squared minus b squared is a minus b times a plus b, but instead we'll raise it a level. This means that a to the 4th minus b to the 4th is going to be what? A squared minus b squared times squared plus b squared, for sure. So which one is that? So far, that either has to be, so it's a to the 4th minus b to the 4th. And so it should be a squared minus b squared times a squared plus b squared. So that looks okay. Oh, the other ones are terrible. That's it? Gotta be that one. Look good. Thank you. So there's an identity that says when you have a to the 4th, the difference of powers of 4 is a squared minus b squared times a squared plus b squared. So when you see the difference of fourths, it's going to be the difference of squares times the sum of squares. And the only one that does that is b. A to the 4th minus b to the 4th is a squared minus b squared times a squared plus b squared. No other one does that. So that has to be the choice. There's a lot more work to do here to actually write this out, but you would then say that, what do we know about cosecant squared minus cotangent squared? What's that?
Kansas City.
No. 1 plus cotangent squared equals cosecant squared. So cosecant squared minus cotangent squared is just 1. This is 1, so that's gone. And then we know that I need to switch this to cosecants. I know that cotangent squared is cosecant squared minus 1. And then you combine them with that. We'll break there, and we'll do the second homework after I derive one of the formulas. We've got what? 7:39. Okay, great. We'll break until, let's say, 7:40, 7:50, 10 minutes.